Hello my dear students and welcome back to my YouTube channel. In today's lesson, I'll be discussing about alcohols. Now basically, what are alcohols? Alcohols are simply compounds that has the OH functional group on its aliphatic chain. Now this is what I mean. Now basically, alcohols have their general formula to be arrow bond OH. Okay, or if you don't write it like this, you say the general formula for alcohols is given to be CnH2n plus 1 OH. Now this is the general formulas for what now? Alcohols. Now basically, alcohols are compound that has the functional group to be what now? Bond OH. So this is the functional group for alcohols, whereby alcohols can be classified based on two mechanisms. Now, the first mechanism in which alcohols is being classified is based on the number of hydroxyl group. Based on the number of hydroxyl group, because this is the hydroxyl group, and the other mechanism in which alcohols are being classified is based on the position of the hydroxyl group. Based on the position of the hydroxyl group. Now basically, talking about classification of alcohol based on the number of hydroxyl group, it is divided into one: monohydric monohydric alcohols. Okay, monohydric alcohols. Now what is a monohydric alcohol? This is simply an alcohol that has only one OH in the compound. So this is what I mean. Now this is an alcohol. This is an alcohol. Now you can say this alcohol here is called ethanol. This alcohol is called ethanol. Now the OH in this compound is just one, so it is a monohydric alcohol. Okay, it is a monohydric alcohol. Now talking about the other classification based on number of hydroxyl group, the other is called, or it is the dihydric. Okay, talking about dihydric alcohols. Dihydric alcohols. Now basically, talking about dihydric alcohols, these are alcohols that has two OH in the compound. Two OH in the compound. Now example, we see the likes of this: H, 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 OH, OH. Now you can see that this compound has two OH, so it is regarded to be dihydric. Okay, and what is the name of this compound? It is called ethane 1,2 diol. Okay, ethane 1,2 diol, because it has two OH in the compound. Now talking more about based on number of hydroxyl group, we have the third one, which is the trihydric alcohols. These trihydric alcohols. Now talking about the trihydric alcohols, these are simply alcohols with three OH in their compound. Basically, we have an example, and this is the example. This is the example. Is an alcohol. You can see we have three OH in the compound. Meanwhile, the compound's name is called propane 1,2,3 triol. Okay, propane 1,2,3 triol, popularly called glycerol. Propane 1,2,3 triol is popularly called glycerol, and it is a trihydric alcohol. Now talking more about based on number of hydroxyl group, we have the fourth one rather, which is the polyhydric alcohols. Polyhydric alcohols. Now talking about polyhydric alcohols, we see the likes of glucose. Okay, glucose is a polyhydric alcohol. Now Poly means you have more than 3 OH, that is the hydroxyl group in the compound. Now, drawing the structure of glucose is simply like this. Okay, this is the structure of glucose. You can see this glucose compound now, the glucose now, it has more than 3 OH, so it is regarded to be a polyhydric alcohol. Meanwhile, naming this compound, it is simply, and you can see we have 6 carbons. Now, basically, the chemical formula for glucose is C6H12O6. Now, we naming this compound is simply 2, 3, 4, 5, 6 penta hydroxyl hexanal. Okay, this is the IUPAC name for glucose. Meanwhile, you can see we have 6 carbons, so it will be hex, and the functional group here is the functional group for alkanal, so the parent name will be hexanal. Meanwhile, we have 5 OH, and the OH here is starting from carbon 2. That is why it's actually 2, 3, 4, 5, 6 penta 5 OH hydroxyl, because the OH is called hydroxyl, so it is 2, 3, 4, 5, 6 pentahydroxyl hexanal, and this is a polyhydroxyl alcohol. Now, basically, these are the classification based on the number of the hydroxyl group. Now, moving on, I said alcohols can be classified based on the number of hydroxyl group and also based on the position of the hydroxyl group. But before we come into this, let's talk more about alcohols. Now, basically, alcohols are divided into 3. Okay, alcohols are divided into 3. Okay, we have alcohol with single bonds, alcohols with double bonds, and alcohols with triple bonds. Now, alcohol with single bond is called an alkanol. Okay, alkanol, while alcohols with a double bond is called an alkenol. And lastly, alcohols with a triple bond is called an alkynol. Okay, now this is the classification of what now? Alcohols. Basically, let's draw a structure using ethanol as an example. Ethanol. Now, this is ethanol. This is ethanol. You can see here that ethanol has single bonds. Okay, so it's regarded as an alkanol. Whereby talking about the alkenols, okay, we see an example using the 2-carbon compound, which is simply this. But now it will have a double bond and is drawn like this. Okay, this is called ethanol. Meanwhile, this is called ethanol. Okay, now talking about alkynol, example, you have triple bonds, okay, and simply drawn like this, HOH. Okay, this is called ethanol. Okay, this is called ethanol. Now, basically, you can see the way we draw the structures here, because carbon is a tetravalent element. It must obey tetravalency of carbon, meanwhile allowing just 4 bonds. You cannot put another bond here when drawing the structure of ethanol. Okay, now this is structure of ethanol, this is structure of ethanol, and this is structure of ethanol. Now, coming over to based on position of hydroxyl group, that's classification of alcohols based on position of the hydroxyl group. Now, we have this. We have the primary, okay? We have the primary alcohols. We have the primary alcohols. Now, talking about primary alcohol is simply the carbon bearing the OH is directly attached to just one carbon. Now, this is what I mean. Now, this is a compound, or this is an alcohol. Now, this compound here is called ethanol. Now, this is a primary ethanol. This is a primary alcohol, okay? Because you can see the carbon bearing the OH here is directly attached to just one carbon, so it is a primary alcohol. Now let's move over to the other classification, which is for the secondary alcohols. Secondary alcohol. Now for you to be a secondary alcohol, you must be attached, okay, the carbon bearing the OH now must be attached to two other carbons directly. Now this is what I mean. Now this is a compound, okay. This compound here is called propanol, okay, precisely 2-propanol, okay. Now you can see the carbon bearing the OH is attached to two other carbons directly, so it is a secondary alcohol. Now coming down to the last part, which is the for the tertiary. So if you want to represent a primary alcohol, it's represented as this. Secondary, this. For tertiary, okay, we have the tertiary alcohols. Now look this example now. Okay, this compound is called 2-methyl propa 2-ol. Okay, now you can see this carbon bearing the OH is attached to three carbons directly, so it is a tertiary alcohol. Okay, it is a tertiary alcohol because you can see that this carbon here bearing the OH is attached to three other carbons, so it's regarded to be a tertiary alcohol. Now basically these are the classification of alcohols based on the position of the hydroxyl group. Now let's quickly talk about the laboratory and industrial preparations of alcohols. Now in today's lesson, I'll be using a very important group of alcohols, which is called ethanol, as a case study. Now let's talk about the laboratory preparation of alcohols. Laboratory preparation of alcohols. Okay, laboratory preparation of alcohols. Now I'll be using ethanol as a case study. Now basically alcohols are prepared laboratorically by reacting alkenes. Okay, this is an alkene, a compound with a double bond, okay, with water, H2O. Now take note, water is also called oxidane. In the presence of a catalyst, which is H2SO4, okay, is an acid, what we get alcohols. We get alcohols. Now basically using ethene, C2H4, ethene reacting with water, H2O. In the presence of H2SO4, we get ethanol, okay, and which has the general formula to be C2H5OH, okay, C2H5OH. Now watch, this is ethene, okay, this is ethene. When addition of water to ethene, we get ethanol, okay. This is ethene reacting it with water, H2O, in the presence of H2SO4, okay, we get this as our compound because the bond of ethene, this double bond of ethene will be broken down. Okay, when you break this double bond, it creates space for these two carbons to bear an atom, so it becomes something like this: H H H H H O H. So this is ethanol, and this is how ethanol is prepared laboratorically. Now let's quickly talk about the industrial preparation of alcohols, precisely ethanol. Now the industrial preparation of alcohols is done by a process called fermentation. Now what is fermentation? Fermentation is simply a microbial decomposition of starch, which is a large molecule now, to form smaller molecules like ethanol. Now, we use reactions now to explain the concepts of fermentation because our sole aim is to get ethanol, okay, industrially. Now, let's talk about the reactions, okay, the fermentation reaction so we get what? Ethanol. Now, starch, okay, starch is a polysaccharide, okay, it is a large molecule, okay, starch is a polysaccharide. Now, starch, addition of an enzyme which is called diastase, okay, and diastase is gotten from malt, okay, because our sole aim here is to get small molecule like ethanol now, whereby diastase from malt acts on starch to give us another macromolecule again which is called maltose, okay. Starch here is a polysaccharide, maltose is a disaccharide. Now, maltose will be acted on an enzyme which is called maltase, which is still is gotten from yeast, okay, to give us a monosaccharide which is called glucose, okay. It's going to give us a monosaccharide which is called glucose. Now you can see here this guy which is called starch is a polysaccharide, maltose is a disaccharide. Now glucose is a monosaccharide because fermentation you are breaking down is the microbial decomposition of large molecules like starch to form smaller molecules like ethanol. Now this is glucose. Now glucose will be acted on an enzyme which is called zymase, and zymase is gotten from yeast to give us ethanol plus carbon dioxide. Okay, now this is an industrial way of producing ethanol. Okay, this is an industrial way of what now? Producing ethanol. Now we have other reactions whereby ethanol is being produced using sucrose. You know, sucrose is a disaccharide formed from glucose and fructose. Okay, now sucrose be acted on invertase. Okay, invertase will be acted on, we act on sucrose, okay, and invertase is gotten from yeast. Okay, we get glucose. Okay, glucose now will be acted on zymase. Okay, zymase is the enzyme that will act on glucose to get ethanol plus carbon dioxide. So you can see sucrose is being converted to ethanol and it's going to pass through these processes. Now, these are some industrial processes of what now? Getting ethanol, okay, which is an alcohol. First thing first, for this reaction, starch is acted on diastase. Okay, diastase will act on starch, and starch is a polysaccharide, and diastase is gotten from malt to get maltose, which is a disaccharide, and maltose will be maltase now, which is the enzyme will act on maltose to get glucose. Glucose is a monosaccharide to give us ethanol and carbon dioxide when it acts on what now? Zymase, and zymase is gotten from yeast. Okay, now these are the industrial processes of production of ethanol. Okay, now let's talk about the properties of alcohols. Properties of alcohols. In today's lesson, I'll be using ethanol, okay, as a case study. Ethanol. Now, basically, ethanol is an alcohol that has a boiling point. Okay, the boiling point is about 78 degrees Celsius. Now you can see that the boiling point of ethanol here is high. Okay, now the high boiling point of ethanol is due to hydrogen bond. Okay, the high boiling point of ethanol is due to hydrogen bond. Meanwhile, ethanol is a compound that is neutral to litmus. Okay, ethanol is a compound that is neutral to litmus. Now, ethanol properties now. okay, undergoes oxidation reaction. Ethanol undergoes oxidation reaction. Ethanol undergoes oxidation reaction. Now, basically, alcohols generally, when they are completely oxidized, so complete oxidation of primary alcohols gives alkanoic acid. Okay, complete oxidation of primary alcohol gives alkanoic acid. I believe now you understand what a primary alcohol is. Now, talking more about the oxidation reactions of alcohols, partial oxidation of primary alcohols gives alkanal. Now, alkanoic acid is also called carboxylic acid, and alkanals are also called aldehyde. Now, the other reaction, oxidation reaction to be precise, alcohols undergo is oxidation of a secondary, okay, secondary alcohol. Oxidation of a secondary alcohol. Oxidation of a secondary alcohol gives alkanone, okay, gives alkanone, whereby alkanones is also called ketone, and alkanone and alkanals are both carbonyl compounds. Okay, alkanones and alkanines, alkanones and alkana rather are both what now? Carbonyl compound. Now, it should be noted that tertiary, okay, tertiary alcohols cannot be oxidized. Tertiary alcohols cannot be oxidized. Now, basically, moving further to talk about other properties of alcohols. Now, we should get a recap now, because properties of alcohol, the first property, I use ethanol as an example. I said ethanol has a boiling point of about 78 degrees Celsius, and you can see the boiling point is actually high, so it is due to a bond which is hydrogen bond. Now, number two is that it is neutral to litmus. Okay, 3 undergo oxidation reaction, whereby complete oxidation of primary alcohols give alkanoic acid, partial oxidation of primary alcohols gives alkanals, oxidation of a secondary alcohol gives alkanone, whereby alkanone is also called ketone, and tertiary alcohols cannot be oxidized. Now, talking about more properties of alcohols is alcohols undergo what we call esterification reaction. Esterification reaction, whereby alcohols now react with alkanoic acid to form esters plus water. And take note, esters are also called alkanoates. Esters are also called alkanoates. Now, other properties of alcohols is that alcohols undergo dehydration. Alcohols undergo dehydration. Now, take note, the first dehydration reaction of alcohol is when an alkene, it's when alcohol now is being dehydrated. Dehydration simply means removal of water. Using a catalyst, concentrated H2SO4, it gives us an alkene. Now, this is what I mean. Alcohols being dehydrated, removal of water, okay, in the presence of concentrated H2SO4 is going to give us alkene. Now, the mechanism at which it gives us alkene is when the temperature is above 180 degrees Celsius, okay, and it is going to give us alkene. But now, if alcohols is being dehydrated, that is still removal of water using the catalyst concentrated H2SO4, okay. Now, sometimes it gives us ethers, okay, ethers. The mechanism at which it gives us an ether is when the temperature is below 140 degrees Celsius. Okay, now, whenever alcohols are being dehydrated at a temperature above 180, it gives us alkene, but below 140 degrees Celsius, it gives us ethers, whereby ethers are also called alkoxy alkane. Now, basically, ethanol is a compound, it's an organic compound, it's an alcohol that has different uses. Now, talking about the first use of alcohol, of ethanols to be precise, is that ethanols can be used as fuel for racing cars and rockets. Okay, and also ethanols can also be used as an antifreeze. Ethanols can also be used as a good solvent. And lastly, ethanol can be used for making perfume. Okay, now basically these are the properties of alcohols, and I believe now we all understand the concept of alcohols, that is the introductory aspect of alcohols. Thanks for watching.